Good day, everyone. I'm Malaya Claire Bacalio. Today, we will discuss the life and contributions of Jaques Hadamard. But before we start, let's have the learning objectives. At the end of the discussion, you are expected to know the background life of Jaques Hadamard and identify their major contributions. The background life of Jaques Hadamard. His full name is Jaques Solomon Hadamard. He was born on December 8, 1865 at Versailles, France. He died on October 17, 1963 at Paris, France. His nationality is French and his profession is mathematician, educator, and researcher. Jaques Hadamard was a prominent French mathematician, known for his depth and influential work across several branches of mathematics. He studied at the École Normale Supérieure and later became a professor at various prestigious institutions, including the Collège de France. Hadamard lived almost a century, witnessing major events like both world wars. Throughout his life, he remained dedicated to advancing mathematical knowledge and promoting rigorous thinking. He was also known for studying the psychology of mathematical creativity, explaining how mathematics thinks and generate ideas. The major contributions of Jaques Hadamard. The first one is the prime number theorem. Hadamard is a most famous for proving the prime number theorem, which describes how primes are distributed among whole numbers. It shows that prime numbers become less frequent as numbers grow larger. His proof relied on complex analysis, particularly properties of the Riemann zeta function. This result is considered one of the most important in number theory.
A prime number is a positive integer that is divisible only by itself and 1. Around 300 BC, Euclid proved there were an infinite number of prime numbers. But how frequently do prime numbers occur? How common are they? To quantify this, let's define a function pi of n to give the number of primes less than or equal to n. This function has nothing to do with the number pi. This is just the traditional name for the function. Here are some examples. Pi of 6 equals 3 because the prime numbers less than or equal to 6 are 2, 3, and 5. Pi of 10 equals 4 because the only primes less than or equal to 10 are 2,
3, 5, and 7.
Next one is the Hadamard matrices. These are special square matrices whose entries are only positive 1 or negative 1 and whose rows are mutually orthogonal. They are widely used today, like coding theory, signal processing, error correcting codes, and quantum computing.
Properties are listed here. The last four properties are equivalent to each other. Here's an example of mutually orthogonal rows and columns. We compare the second and third rows of this Hadamard matrix. In the cells marked with blue, the values are equal, and in the cells marked with red, the values are different. Between every pair of rows and between every pair of columns, half of the cells are equal and the other half of the cells are different. Another property is that a Hadamard matrix times its transpose equals n times the identity matrix. In this case, n equals 4. For example, computing the dot product of this row of H and this column of H transpose gives the diagonal value of 4.
Hadamard inequality, an important result in linear algebra that gives an upper bound for the determinant of matrix. This is used in geometry, optimization, and matrix theory. And that's the life and contributions of Jaques Hadamard.